today, the topic that we're going to be discussing is biodiversity measurement in agricultural landscapes. And for that, we have with us Daniel Hernandez of Fundación Global Nature, which is our member organization in Spain. Thank you so much, Daniel, for kindly accepting to do this. And we also have Oliver Bach, who is joining from Colombia, from the Sun Secretariat. So we will be covering several topics with the two of them, and then we will invite everybody else to participate in the discussion. So first we will have Daniel explaining about the FGN Biodiversity Gain Initiative that they have been developing. Then we will hear some academic trends on the topic and case studies on agrobiodiversity. And then we will discuss about a common vision for SUN as a network on this area. And finally, we will have questions and answers so that everybody can get involved some way or another. So that's everything from me. I leave it to you, Oliver and Daniel.
Thank you, Anna. Well, everyone is aware about the biodiversity crisis, and of course, it's part caused by agriculture, pesticide use, habitat destruction, etc. Every month, almost, we read shocking numbers about the reduction of the crisis of bird populations, amphibian populations, insect populations, even. But well, here we are with SAN to look for solutions, and this is what the session is about, and we hope to have a good discussion with you. So crucial for achieving the sustainability goals around biodiversity are biodiversity assessment tools, and this is what this session is about. But well, in a nutshell, and I have a little bit more information around those lines, the most of the existing systems for biodiversity assessment are not suited for agriculture or for smallholder farmers because of their scale. There are several, well, I've did a little bit of surfing around ResearchGate, recent publications, and many companies are starting to publish their nature performance, biodiversity performance. For food and agriculture, it's only 2% out of 50 top revenue global companies. And the most measures reported around biodiversity is species abundance only. There are almost more biodiversity assessment methods than species in the world, one could say. There's, well, I've been trained during my wildlife management master program on field surveys, right? Mist net trapping, traps, camera traps, line transects, point counts, everything around calculation, the different biodiversity indices. There is looking on Earth from space, right, for measuring landscape and habitat characteristics. The newest technology is very able to even distinguish different canopy types or distinguish an oil palm from a forestry. There's molecular methods there on the rise, environmental DNA, that's part of Danielle's talk. They're on the rise, definitely. Very promising techniques. And there's a big portion of the population that likes bird watching, so amongst other nice animals, and so there's a strong trend around citizen science. But the main challenge is to get scientists, policymakers, and communities together and really design scientifically robust and socially relevant indicators. And I would stress socially relevant, and I think this is one of the strengths of our global impact network as SAN, right? So most of the global models do not reflect the local reality because they're just too coarse. You cannot check out from a satellite image the biodiversity status of a coffee farm, for example, right? At the Indonesia General Assembly, I already summarized. I had a look at 10 other systems, and they're basically not suitable for agriculture. There's one standing out, Biodiversity Performance Tool Consortium, co-authored by Fundación Global Nature. We will hear more from Daniel later on. And well, is There's around 50 or more biodiversity assessment tools currently online that industry or stakeholders can use. But as I said, the challenge is to have something for agriculture. Most tools require expert input. They are too complex to be used on smallholder farms. They are only suitable for landscape scale, not for farm-specific indicators, and they lack information around, for example, pesticide impacts or the severeness of pest attacks. The severeness of pest attacks is an indicator of ecosystem health, right? So with that, I think I've said enough. I will stop sharing my screen, and Danielle, please, the floor is yours.
Okay, thank you. Apologies beforehand because you will see me talking through my phone. I'm just talking to you, but I'm in the middle of train stations because of a cancellation of a train ticket, and I need to do the Agrotalk from a cafeteria. So apologies beforehand, but although you see me with my phone, I'm talking to you. I will share my screen. Thank you very much for being here, by the way. And here it is. You can hear me correctly, right?
Yes, perfectly, Daniel. Thank you.
Excellent. Thank you. So, as Oliver and Anna were saying, we've created and implemented for the last 2.5 years an approach to monitor biodiversity gains in agrarian landscapes. We are an NGO, we are Global Nature Foundation, we're part of the Sun network. And what we do basically is to implement projects in agrarian ecosystems to improve biodiversity. And we realized that we wanted to quantify what we were doing in order to be able to generate pieces of communication for regulators, policymakers, companies, potential investors, so that we can claim with robustness the increase in biodiversity that we were achieving. So what we did is we dug a little bit, and we found several methodologies that could potentially be used in agrarian ecosystems, and which we started to implement them to measure biodiversity there. The problem is that, as we'll see during the presentation, biodiversity in agrarian landscapes is very tricky to measure because it is an ecosystem that resets itself all the time, as you'll know, as agronomy experts and part of the Sun network, through the application of pesticides, tillage, fertilizers, different crops, crop rotations. So traditional approaches weren't the most efficient for us to be able to measure things. So we tried a couple of other methodologies, and in the end, we came to the conclusion that the products that were available to us, those 45 methodologies or even more that Oliver was talking about, weren't suited for our needs or the needs of our clients as well, or the regulators that we talk to. So we decided to, with the knowledge that we had and all the data that we had, to create our own methodology. We don't have an economic interest in this methodology. We don't earn money by verifying with it. We don't earn money by somebody else using the methodology. It is open source, and we just use it as a communication tool to be able to communicate to the different stakeholders the biodiversity increase that we are getting in the places in which we work. Although I said that other methodologies aren't suited from our point of view to agrarian ecosystems, let's be clear, those methodologies might be excellent for coral reefs, forests, pastures, other types of ecosystems, jungles, in which we have less human presence and we are not subject to those dynamic circumstances of agriculture. But in agrarian ecosystems, we needed something different, and that is why we created this, and we want to share it with you, together with the case studies that we'll comment on later. And now I will start. What challenge are we solving? Agriculture is one of the main drivers of biodiversity loss, but agriculture depends on biodiversity for productivity, quality, and long-term resilience. So is regenerative agriculture, for example, truly improving biodiversity? The thing is that, as I said, existing methodologies or existing data is super generic, so they don't comply with the necessities of measuring in agrarian ecosystems highly dynamic, as the one that you see below. the data available isn't at plot level, so we are looking always at the landscape, and when we have agricultural plots scattered throughout the territory, it is very difficult to ensure that the biodiversity gains or losses that we are measuring are due to the interventions taking place in our plots. They might be other features or circumstances at the landscape level. So the available data doesn't reflect farming practices, so it is very broad. So we are never going to be able to divide or separate what is being due to the application of organic matter, what is being taking place, the improvement that is taking place because of a cover crop or less pesticides, because the data is just not accurate enough. But regulators and investors need measurable nature outcomes, and marketing and business departments in agri-food companies, for example, need to communicate nature impact. So what did we do? We created this methodology that provides a way to show with a high degree of confidence how our field interventions improve biodiversity and ecosystem health. As you can see there, through different biodiversity groups, such as soil biodiversity, pollinators, predators, endangered birds, those kind of things. So what does the methodology do in simple terms? You have the link to the methodology throughout the presentation in several places, so you can check it out later. But in simple terms, what we do is we measure biodiversity gains or losses caused by a specific reject farming practices, and we express them in a simple metric that can be percentages of increase of biodiversity per hectare and per year, or biodiversity units. Understand that a biodiversity unit is a 1% of gain in that percentage of increase of biodiversity. This methodology provides credible science-based evidence that reject or any other type of intervention that we do in agricultural landscapes is delivering value, and it's been co-created with external R&D departments of agri-food companies, which are ones of the most interested in this area, apart from many other projects, also public projects that we run and that helped us through research, through other studies, research, or implementation on the ground to keep on gathering data and define what the methodology needed to cover. It can be used for reporting, communication, and strategic decisions in a standardized way. We compare fields. The set of indicators have been scientifically validated. Indicators, as we'll see, are features within biodiversity groups that define what agrarian biodiversity actually is. And this methodology allows us to create a clear roadmap to identify the best practices with real impact to implement on the ground, and to quantify the amount of biodiversity they are producing and the cost that they have, so that we can make better informed decisions. And as I said, it overcomes some of the challenges of agricultural monitoring. Some of them are, for example, as I said, traditional approaches are based on measuring in year 0, then in year 1, 2, 3, and see the progress. But in agriculture, since you have crop rotation, maybe the first year you measure a cereal, in the second a legume, in the third sunflower, in the fourth another legume, in the fifth another cereal. So the biodiversity improvement or the decrease in biodiversity is not only due to reject practices. In this case, for example, it can be attributed to the different crops that we are measuring. So we need very long term monitoring events to take place so that we are ever going to be able to quantify biodiversity in a good way, mostly 5+ years. Also, another constraint, the climate. In the circumstances that we work in agriculture, sometimes we have semi-arid conditions or arid conditions. If in year 1 we measure and it's been a rainy year, and in year 5 we measure again and it's been a dry year, then we are going to lose biodiversity, but not because reject doesn't work, but it is just because in the first year it rained a lot, and in the 5th year it didn't rain that much. So those are the types of challenges that we can only find in agrarian ecosystems that this approach that we share overcomes. Why biodiversity units matter for the business or for us? These biodiversity units allows allow companies to claim measurable biodiversity improvements and back everything, and sustainability and reject narratives with actual empirical data. They allow for storytelling, creating a narrative around biodiversity. They are aligned with CSRD reporting and other regulations. They show the practice that are more that have more priority in terms of ecological value. And it helps to answer the question, some questions such as, for example, does reducing pesticides increase ecosystem resilience? We can quantify it and say if it is true or not, and at what degree. Do ground covers improve soil health? We can know it through this approach. Do hedgerows increase natural pest control in the crops growing next to them? We can also know that based on this monitoring mechanism. The results, this is another very interesting feature of this approach, is that are available in the very short term and aligned, therefore, with business cycles. So in other approaches, you need to wait at least 5 years, if not 10, to be able to claim anything in an agrarian ecosystem because of the dynamism that I said takes place there. But through this approach, you can have results in just 1 year. Okay, you can give a guidance and projections on the biodiversity increase that you might expect, so that companies, regulators, administrations can make informed decisions in a very short period of time. We are avoiding the risk of waiting 5 to 10 years to know if our practices are actually working or not. And maybe after 10 years, you are disappointed and they don't work as they should have. So our approach considers what it's called a basket of metrics. It is something that other methodologies consider as well. We assess basically 4 biodiversity groups. That is what we call metrics, that together reflect the health of the ecosystem. Those are soil invertebrates or soil life, and through that we are able to assess soil health. We assess flora for habitat quality. We assess above soil invertebrates, among them pollinators, predators, parasitoids, and we assess birds. So 4 biodiversity matrix or biodiversity groups that live within the agrarian ecosystem, that affect the ecosystem services that this agrarian ecosystem provides to agricultural production, and that are affected by, and the production that is taking place there is being affected by these organisms as well. And the activity affects these organisms. Within each metric, the metrics or the biodiversity groups are not indicators. So bird is not an indicator. Flora is not an indicator. Within each biodiversity group, we have different indicators, such as the QBSR or Soil Biological Quality Index, the indicator abundance, the indicator richness, the indicator interest, or for landscape, when we talk about landscape, the connectivity. So a biodiversity group is not the indicator is the different pieces of information that we are able to gather within each biodiversity group. This data is aggregated into what we call into biodiversity units using what we call the biodiversity matrix, which is something that you will be able to see in our methodology when you check it out. And that is the way we find more appropriate to aggregate the biodiversity data of different indicators, different groups of biodiversity, and being able to put everything together to come up with a percentage in the end that we can communicate and claim on. And this is the first part of my presentation, and I will give the floor to Oliver now. Then we'll see the case studies after that, and then we'll have the discussion. So please feel free to write your questions in the chat, or just remember them for later, just to talk about them. Thank you.
All right. Thank you, Danielle. This is really one of the most promising methods for SAN as a network. But let's discuss how we could implement it in the future in the different countries in the tropics. And I've recently in October attended the Swedish Biodiversity Symposium, and apart from, of course, there are outstanding universities that participated and organized the symposium. And we got at least 3 scientists committed in the future to do some work with us together, being it research, implementing projects, or proving impacts. There's some additional input of relevance for this talk. So, well, of course, there was a biodiversity assessment session, well attended. It's biodiversity conservation and assessment is receiving increased attention. So there was a very hot session at the conference with many questions that scientists still yet have not answered. One of them was presenting around oversimplification, time lags, their baseline issues, scale mismatches. Well, a very technical everything, right? One of the contacts that could work with SAN in the future is Faith Jones, and I would like to summarize some important messages from her research findings. And it's around, when there are stressful situations for biodiversity or species assemblage, species compositions, such as, for example, on a farmland or in an agricultural landscape, there are several things that are happening, right? So the environmental stress filters, such as monoculture, pesticides, etc., will affect certain species more than others, and that's very important to have in mind. So some species will become more abundant in those agricultural landscapes, and other less tolerant species, more specialized species, will become less abundant, right? And there's the risk that rare species eventually get eliminated. No, there's quite some publications in Germany and other high industrial agriculture countries around the effect of agriculture on the elimination of some very specific bird species, for example. But there's something that we need to keep in mind, because when we on a farmland, on an agricultural landscape, alter or change the landscape or the habitat, then immigration of other species will happen. So there's immigration of non-native species or invasive species, and that can lead to a rise of biodiversity or indicators, right? For example, local species richness. So that's something we need to have in mind. It's very technical, but important input for our discussion. So of course, general species are often more favored than specialist ones. The generalist ones are resilient and robust. They can thrive almost everywhere. They won't be that much affected. Focusing only on the abundance of common species will be drawing a wrong picture, and we don't want to do that, right? So in a nutshell, there needs to be a mix of biodiversity indicators, such as Daniel already has highlighted. So the number of species is very important, or the basket of metrics that Daniel proposed, but also counting the number of rare species that will tell us about the quality of the habitat and how that quality of the habitat will evolve over the time once we're starting to implement region ag practices or the like. There's one thing before I handle over again to Danielle that I would like to flag. We should not underestimate the effect of pesticides. As you can see on the right, out of more than 800 currently active pesticide ingredients, there's a lot, around 9 to 13% with environmental risk. And there's also quite some that are categorized as highly hazardous pesticides. Around 10% are extremely or highly toxic, so they affect mammals, for example. Also human beings, workers, of course, that work on the farmland. And there are others, very nasty ones, that are persistent organic pollutants and end up in dolphins and whales and other animals out in the ocean. Those DDT and other substances have been, for example, detected. So it's not a wise idea. On the left, you can see what I highlighted in orange, please. It's not only valid to emphasize on the conservation and restoration of some natural habitats, for example, in the case of wild bees, to promote them, because these strategies, as these researchers have proven, are totally insufficient to mitigate pesticide-driven losses of wild bee pollinators from crop fields. So, for example, when we implement flower strips, we should always also have as a parallel strategy to substitute highly hazardous pesticide or reduce the effect of nasty insecticides. And with that, I hand it over to Danielle, and let's then have the discussion, please.
Okay. Hello again. Now we are going to show you how this looks like in action. Okay. These are two true stories that are taking place in some of our projects, and this can give a flavor for the possibilities that we unlock through the implementation of this type of approaches and the narrative that we can generate around biodiversity that is actually super sexy and can be translated into the landscape scale very easily. So, for example, let's travel to a steppe habitat in central Spain, a steppe habitat in which our project area is comprised by 343,000 hectares. That is the circle that you see there. That is the landscape. So it is a steppe area with extensive agricultural lands, semi-natural habitats, also natural habitats as you see here, pasture, forests, dehesas, and those natural habitats are the pieces in green, and they cover 43,000 hectares in our sourcing region in this case. Urban areas as well, there is a city just in the middle of it. So this is the landscape in which we work. Within this landscape, we have the possibility, and we did for the past 5 years, we worked in these surfaces. So that is the surface covered by arable crops of the farmers that we work with. The surfaces in yellow are comprised by rain-fed cereals, rain-fed legumes, and rain-fed oilseeds. Okay? And they are scattered throughout the territory, as I said before. Agriculture sometimes is not just an homogeneous space. The plots are scattered, and we need an approach that is able to comply with that circumstance. Then, from all those surfaces in yellow, now we see surfaces in orange, which are the surfaces within the farms that are going to be covered by cereals in the following campaign, okay, 2025-2026. That is the area in which we've been focused in the past years, or we are focused in the project. Those are the cereals, although we have in the rotation legume and oilseeds as well. We very much work on the cereal plots. So from the 6,500 hectares, we go to 4,337 hectares in which we have the possibility to impact directly this year. And in those hectares, we implement a project, a regenerative agriculture project, in cereals for baby food consumption. Those cereals are wheat, oats, barley, and we've managed to reduce from 2023 up until 2025, 33% of the nitrogen used. Translated into kilograms of chemical fertilizer, it is something like 2.5 million of kilograms of chemical fertilizers reduced in this sourcing region within those years from 2023 to 2025. The score in REJAG has improved from 900 to 1,330, and the carbon emissions have been reduced by 50%, and that entails 6,152 tons of CO2 equivalent. And although for us as experts, these numbers tell us something and they are very meaningful, they are highly intangible for the general public. For example, what is nitrogen? What is a fertilizer? What is REJAG? what is carbon? What are tons of CO2 equivalent? So although the impacts are super nice, they are difficult to communicate and to like put in create value through them. So what did we do? We went for the cherry on top, that we say, which is, for example, in this area, these purple plots in which we've implemented vegetated fallow lands, 350 hectares of surfaces that instead of being planted with crops, have been sown with flowers for biodiversity, not only for the sake of biodiversity itself, but improve pollination services, biological pest control services. So they are a win-win for everybody. They are scattered throughout the territory, and the impact of these fallow lands is not just applicable to the exact surface that they cover. They are actually impacting in what we call biodiversity-friendly areas, which are those areas that you see there, that are the areas in which pollinators or birds are moving, and they can just have this like fallow land in the middle, and this fallow land is acting as a connectivity, an ecological corridor for this type of organisms to move throughout the landscape. Those purple circles are also connecting the fallow lands to the natural habitats that you see in green. So the ecological connectivity increases by 25,000 hectares just because of these fallow lands, together with the other practices that we do within the program: organic fertilizers, biostimulants, direct no tillage, less use of pesticides, those type of things. So throughout this biodiversity unit methodology, we're able to say with full traceability of the data and verifiability that we achieved a 76% increase in biodiversity per hectare per year, which is 76 biodiversity units, and at the landscape scale, 26,000 biodiversity units in general. But these numbers are still like intangible, and we are trying to make tangible what was previously intangible. Carbon, fertilizers, rejag, biodiversity units, percentages are intangible. But this methodology allows us to create a narrative around the organisms of interest that we can prove are present within our sourcing region because we are doing the activities that we do. So, for example, there are endangered steppe birds, such as, for example, the Eurasian skylark, categorized as vulnerable, that you can see there. That species is significant. The activity of that species is significantly higher in the places in which we work compared to business as usual situations. Great bee flies, bioindicators and pollinators, meadow grasshoppers, and specific species, which is an indicator of steppe habitat health. There you can see the methodology. If you click there, hoverflies, which are predators but also pollinators, Braconidae, so some parasitoid wasps that allow us to control pests of the cereals, and Pteromelidae, another parasitoid wasp that allow us to control those type of organisms that impact negatively our crops. So this is the type of stories that we can create through this approach. It can be applicable to cocoa, coffee, whatever it might be. The spirit is the same. The interventions would be different, but the way of measuring it is pretty similar. I had also prepared the business case for processing tomato in Spain as well, a vegetable, but the spirit is the same, and I think I exceeded my my time allocation. So I hope it was clear through this case study the different possibilities that we can unlock. And of course, when we do this, we are now at the stage of when we go and measure, we go with video cameras, we film the organisms that are going to appear in the eDNA, in the bioacoustics. So later, when we do this claim, we can also show the specific plots that we measured. We can show the bird that was singing and that has been recording in our devices. We can photograph the pollinator that was pollinating the flower and that appeared then in the eDNA metabarcoding analysis. So this unlocks a lot of possibilities, and I hope we can discuss them in the following section, in the discussion section. Thank you.
Thank you, Danielle, and for the discussion. Well, this is an outstanding, as you've observed and listened, methodology the storytelling around the species has a huge potential to attract the attention of business, of consumers, and other stakeholders. I would love to see this methodology in an adapted form being implemented throughout the SAN network.